Welcome to BISP Solutions, and our today's bootcamp session is all about the application of perceptron. Right, in our last two sessions we have seen what, and here single layer and multi-layer perceptron. Now in single layer, today I will show you two examples in which perceptrons are used. Right, in my very first video I have shown you in my very day before yesterday. On that session we have seen how perceptrons are when there is an output of 0 and 1, right? So when there is an output of 0 and 1, we use this single layer perceptron, and perceptron is just like a neurals, right? For example, if you are either 1 or 0, either yes or no, so in that case I will take decisions immediately. But whereas in multi-layer perceptron, there is a different criteria on the basis of which the decisions are taken. But right, today we are not going to study on this theory part, because it is already we have discussed. First of all, see here, if you see this image very carefully, if I y means dependent variable. In this y, dependent variables are used. X means independent variable, w means weight or the coefficient, and b means bias. Activation function is f. So here same thing is here. First of all, we will take the input data, then we will optimize that, we will fit the data, we will divide that data first into the basic dependent and independent variable, and on the basis of that we build a training loop. Now again, the 80% for training, 20% for test. All this we are doing just for extracting the data. For example, if I take here take an example of the student, where the whole year the student study, and then out of that 100%, only 20% is asked for test, right? But the student has to study all the data, right? So that is what we are doing here. Right, now in this case, this is the complete mechanism how it works. First of all, object, then object is converted into the tensor, then tensor means it's a type of what we say, the matrix. If you have seen the right face recognition machine in which the person stands in front of the camera, so that is also, first of all, your face is captured. After that it is converted into tensor, and that tensor is matched with the database images, whatever your database images are. Now database image, it will match approximately 95%. Why? Because suppose today you have registered your face in that face recognition attendance machine, right? After that, daily you will come with different hairstyle, or if someday if you come with different hairstyle, then also that machine can be able to recognize you. So in that also tensor is used. So how it converts? First of all, it will capture your face, then on the basis of some certain points your face will be converted into image. That image will be converted into tensor, and it will be matched with the database images, whatever the database it has, and in that case your face will be matched. Okay, tensor is matched, maximum approximately match, and then you will see, okay, welcome, you will hear the voice welcome or thank you, right? So similarly here the tensors are used. Second point, suppose just a second, let me take one more notepad here. One is face recognition attendance machine, right? Face recognition. Secondly, traffic signal, traffic light. There are many AI enabled cameras, right, in which in America, so what happened, the camera is fitted on the traffic signals. In that case, that camera constantly take the images, photographs, and it will check whichever person has not wear the helmet. If a person is without helmet detected, immediately its face is flashed on the big screen on the road. So that is the warning, and if the person is not is ignoring that warning, so immediately the challan or the receipt, the charge, whatever the charges are there, it will be sent to the home. Third thing, on highway for speed recognition, for example, the AI enabled camera, right? What AI enabled camera does, it constantly takes the images, and first of all it takes the image, and if the car exceeds the speed limit, for example 100 km per hour is what we say, approved, but if you go, charge will be sent on your home. Third thing, in big what we say, big festivals, or we can say where the high gatherings are, gathering of the people, right? Just now recently in India the Mahakumbh was held, so in that 60 crores of people, they gathered together, right, in Mahakumbh. So what happened there, also AI enabled cameras are installed to recognize the face. So these are, so that is the power of tensor and image recognition. In our upcoming videos I will show you one example, also upcoming sessions I will show you one example of how to recognize the face. I will show you one image stored into the database, and another image I will for the input purpose, and both the images are different, right? One person wearing white shirt or any other color shirt, and then another same person but with not exactly the same photo, right, clicked with different angle, and I will show you the matching of these two, how they are matched, right? So this is how the use of tensor is. That is why this tensor is most important, right? Now this is for image, but for mathematical calculation part also tensor is used here. Now suppose we are having two databases. I have taken one company database in which employee health related data is given. For example, if I show you, look at this, health related everything, employee diabetes data, glucose, BP, skin thickness, insulin, BMI, the body mass index, the diabetes pedigree function, age. This is the data of the company, right? And based on that we will detect that whether any person, what are the chances of any person that the diabetes symptoms will be visible in that person, right? So what are the chances that the person will have the diabetes in future? That is what we are extracting with the help of this perceptron, right? So I will create a fresh copy for you, and then we will work on it. Now here perceptron diabetes, I will create a new, completely new, right? So let's create a new Python IPython file, perceptron diabetes bootcamp, right? So let me create one new, perceptron data. First of all, see again one thing, we are having a set of data, historical data, and in that historical data there are so many criterias. They are just an example. For example, if you see a doctor also, the doctor also checks the past history of and then he make decisions for the new upcoming patients, right? Same thing is here. We are having historical data, in that the total 700 people are there, in which different criteria are given that this person was having diabetes and these are the criteria, this person was not having diabetes but these are the criteria. So based on that we start our first example, that is So first of all, we are now recognizing that making the prediction that which person will be having diabetes in future, right? So first of all, we have to import some libraries. One is the Torch library. Now Torch library, in that NN is the main library. Torch.optim means optimization, then classification, after that train and test split, then the standard scaler, right? And here is the matplotlib for plotting the data, numpy for calculation, and pandas is most popular, that is for data massaging, right? So now I am just entering the data. Now it takes a little time, 3 to 4 seconds. So let's wait for this, and then after that we will go with the another set of data, that is we have to read the data, right? Now we have to read the data. First let's wait. Now I will, now see here we are just reading the data. Now see, I am having this data. Now see what this row says, that a person having no child, but the glucose is this much high, blood pressure is this, and based on this also the person was having diabetes, right? So all this 0 and 1, right? So this is, we are having the data in the numerical format, and Perceptron also works with numerical data only. There should be no alphabetic data. Okay, now see here, another is outcome. Okay, so I will just now see here again, same thing we have done. The main process is to separate the data into dependent and independent. Now independent data means what? A person's weight, a person's thickness, which is not dependent on anything, a person's blood pressure. So these are called the independent variables. X value, outcome is the dependent value. Okay, so if I type here X, look at this, and if I type here Y, look at this, right? So we have changed it. Now our next part is X-train and X-test, right? So X-train and X-test means, see here, X-train and test. See, whenever we are having data and then we separated the data into numerical parts, we divided that data into train and test. Now what happens? Variable and independent and dependent variable. Now the test train split happens here. Now here what we are doing, we are taking 70% to train the data and 30% to test the data. That is what we are doing here, right? And random state 42 means we don't want to change the data. For example, if you might have seen in the Excel sheet, there is a command that is RAND, randomly created, random creation of the numbers. If you every time if you enter the button, you will see another number is generated. Same thing is here the number should not shuffle, so that is why here we have written random state 42, right? After that, what happened, we are now see here what we do, standardized scale, standard scale, right? If you see here somewhere in the, okay, now see here, scalar equal to standard scalar and X-train scalar dot fit transform. So we are just fitting the data and transforming the data in this X-train test, right? Now suppose if X underscore train dot shape, look at this, shape means total how many columns are there. Similarly, now after that what we need to do here, convert them to Python Pytorch tensors. Now tensor means again the computer understands the tensor language. Computer does not understand your Excel sheet or whatever, the Pytorch does not understand your Excel sheet or whatever you have. Pytorch understand only tensors. Okay, so now X train tensor, Y train tensor, X test tensor, Y test tensor, right? So in this way we have converted them into train and test tensor, right? We have converted them to tensor. After this, now see here, define the perceptron model. Here you will see here, now see perceptron model. What is this perceptron model? This is the standard model. You have to just write down as it is. Here activation model is sigmoid, right? Sigmoid is used, and sigmoid is the main function which is used by Pytorch. Now we have the next step is input dimension. How many dimensions are there? That is the number of columns. After this, look at this, initialize model, loss and optimizer, right? Model equal to perceptron, input dimension, and then define loss and optimizer. So creation equal to BCE loss. We are using here BCE loss, means whatever the loss means, whatever the difference between the actual and the predicted data, it should be as less as minimum. So binary cross entropy loss for classification purpose, right? That is what we will use here. Optimizer means optim.sgd model parameters. So this is the standard step, and then we are going to we have to wait here for 2 seconds. After that, step 4, that is the train model. Now see here, epochs we have used. Now how to train the model. See, whenever if you want to train, let's take a daily life example, like you want to train a boy, or you will ask him to repeat the same exercise 1000 times, right? So this is how we train the human being. Same thing is here, number of epochs, that means number of repetition, that is 1000, and here epochs in range, number of epochs, right? Now output model, optimizer, and then we are giving the data. And now what will you see here? Look at this. Suppose if I make it 5000, let's take 5000. Look at this. So that is why we are doing it only 1000, right? After this, what we are doing here now, that is most interesting. Let me show you that. Now see here, suppose if I make it as 5000, let's take an example of 5000. And now I am going to again hit the enter button. Look at this. That means we are going close to the perfection. See here, this is the loss line, and we are going, our loss is minimizing, right? So in after every repetition, so that is why we use here train test. So now let's make it again 1000, and then wait. Okay, each time it is showing different. Let me remove this, right? And now I will again, let's do this 1000, right? That exactly how it works, right? Then what we will do here, we will now plot the data. Okay, sometimes it shows error also. Now suppose let me start with the beginning, right? So let's start with the beginning. After this we will go here, then I will go from here to here. Okay, then I will go here. Right, now look at this. Now this is how we are going very close. Our loss is now reducing. After that, what we will do? Now here, okay, plt dot show here, right? And then what will be our next here? That after this we will go, right? Now see here, accuracy is 71%. So with torch, no gradient, y prediction, model, x test tensor. So here we come up to the accuracy up to 71%. If we increase the number of repetitions, or we can say epochs, like 5000 in place of 1000, our accuracy will become more, right? So that's the reason here. After this, step 6, predict on new data. Now see here, prediction on new data. What we are going to do now here, first let's see this top side. This is row 1 means 1% data, row 2 means another, row 3 means another, row 4 means another. Similarly, we have given the data of a single person. That means 176 is the what we say, the weight, right? Glucose, this is the glucose. First is pregnancy, then the blood pressure, and all these information we have given it comma by comma, right? After that, the torch dot no gradient, new prediction, right? New data tensor, then new prediction class we have given greater than 0.6, and then if is yes, if it is not 1, that means diabetes no. Now see here, probability is 57, that means 57% chances are there that he might be having diabetes in future. Prediction class is 1, predicted class is 1, that means yes, diabetes is yes. So in this way we predict the data, right? Now where it is used, for example, this is just an example of diabetes. It can be used in stock market also, it can be used in corporate data. For example, the corporate data. Now corporate data is having the company is having a plant of cold drinks. Now company is having 5 years past year data, historical data. Now based on that data, the company faced so many hurdles at that within the last 5 years, like sometimes the sale goes high, sometimes the sales of cold drink goes very low. So company has maintained the data, right? And based on that data we are going to predict. So here we can predict that this time whatever the how much will be the sale is going to be. So these are some scenarios that I have explained you, that why tensors, why perceptron is used and where it is used, right? Now second thing, loan eligibility. We will create one more, I will create one more separate IPyNet file, and now again same thing is here, loan data. Now loan data means exactly what? Loan data, for example, if a company is having some data, we have taken this. Now there are so many people, those who take loan and those who does not take loan. Now we are having the data that in which we are having the number of people, name of the people, those who have taken loan, and we are having the name of the people, those who have not taken the loan, and we are having all the inputs from those people. For example, there could be so many people, those who are having rental house, they are having only one child, but still they do not take loan. Then there might be some persons that they are having good amount of salary, they are having own loans. So what was the reason? So we have taken all the inputs based on that. After that, we input all these data into a machine that we call as Perceptron database. Help of this Perceptron, we will take loan, or he will send their money in different someone has spent field like different field like charity, the traveling, the tourism. Now based on that, one new person comes to me and he has given all his data to me. Now based on these people, I will predict that okay, what he will do with this money. So this is just an example, right? Example scenario. Okay, let's move to our main task, right? So let me go here, Perceptron loan data, bootcamp loan, here loan data. Okay, now here yes, now we have entered into this. Okay, now I am creating one more iPineUp file. Look at this. Here I will create one. So loan eligibility status here. Bootcamp. Okay, now what we are going to do here, we are just working on, okay, now see here, loan eligibility status, how many people are eligible for loan, right? So who are taking loan, or who are willing to take loan. So this thing also can be extracted. Now I will show you how it is done. So first of all, see what happened, we have to first import all the necessary libraries, right? Now again the same thing, why I am repeating this, that you will memorize, right? Each time when I repeat, you will memorize it. Import torch is a big library, torch.nn is the main basic library, important library, right? Then the optim for optimization, make classification, train, test, split, standard, scalar, all these, right? NumPy as NP, pandas as PD, very popular library which is used for data massaging, cleansing, everything. Now I will just hit the enter button and wait for 2-3 seconds. It takes a little time, first time, right? After that, we have to read the data also. Now here is loan data, we are already having the loan data, right? So what we are going to do here, loan data. Now data is here, we have received the data. Now what next? We have received the data, and now these alphabetical values are also there. Now we don't need these alphabetical values. Why? Because again the same thing, the Perceptron, all techniques, they work only in numerical value, right? So look at this, person gender, male for 1, female for 0, associate 0, bachelor 1, masters 2, doctor. That means everything is mapped with numerical data. Now again, if I make it like this, look at this, all the data becomes numerical. Clear? Now what our next step will be, look at this, Now separation of the data into dependent and independent variable. Now see, in this X we have dropped the loan status column and remaining everything will remain the same, right? So, and here this means y equal to data loan status, only that loan status is inserted. Now clear it is. And after that we will execute. First of all, data dot drop loan status X is 1. That means we are just deleting the loan status column. Y equal to data bracket only loan status. So now what will happen here? X, look at this, Y, right? Now we received this. After this, if I type here X shape, look at this, 4500 is the row total, row number of rows, 13 means column, total column 13. After that, now we have separated the data, we have converted the numerical also, then we separated the data into X and Y, that means the dependent and independent. After that we have entered the train test. So now what we are going to do here, see here we have transform fit, that means we have to fit the data into the scalar, that is a it is one type of library, right? We have to fit the data. After this, what we are going to do, then we will convert this data into the tensor, right? Now see here, X train tensors, every data is converted into tensor. Why? Because the perceptron understands the language of tensor, it's a matrix. Now after that, very few things are remaining. Now define perceptron model, again the same thing. Now define perceptron model. So here we come, this is again the perceptron model, this is fixed, right? Here sigmoid is used, activation X and then return X. Now after this, input dimension X train shape. So what we are going to do here, if I put here input, these are the 13, that is the number of columns here, right? After this, initialize model loss optimizer. Model loss optimizer, see here binary cross entropy is used. Model loss optimizer is just for what we say, calculating the difference between the actual and the predicted value, right? Now next step is, now here we are running 2000 epochs, because we are training the data, clear? So here epochs are running. After this we are plotting the data. It is still running, we need to wait. Now see again the same thing, the more epochs you are running at this point 1000, you will see this point comes here, and in the 2000 it comes here. If you run more than 2000, it will come very close to the perfection and the accuracy, clear? After this, what we are going to do, look at this, 88% it is accurate. It has given the accuracy because we have included the epochs. So in the training purpose of this data, the more epochs or the more repetitions you runs, it becomes more accurate. After this, now it has become more accurate, we know that 88% it is successful. So in that case, what we have done, we have given this data of a personal individual person, and now we have run the data. Now it will convert into scalar transform, then the tensor.torch, then torch.no gradient. All these function is done, and finally what happens, predicted class is 1 and loan status yes, that means this person will be eligible for loan. That is what this prediction says, right? Prediction, the prediction can be done on any type of data. For example, I am having the school, let's take an example of school. School is having the data of last 10 year students, and based on the performance from 1st standard to 10th standard, school can predict this year how many students will go to will take mathematics as their main subject, how many students will take commerce as their main subject, because we are having the history of last 10 years students, and based on that, so this machine learning, or we can say the perceptron, is all about prediction of data. For example, just take a very simple example. In a family, if a child has obtained 40% in 9th, 42% in 10th, automatically in 11th standard the father will say, don't take mathematics or biology, this is not a cup of tea for you, and they will suggest that child to take arts or any other subject. So perceptron or the machine learning predictions, these all are depending on the historical data, and taking the historical data as a reference and making some calculations and prediction of the future, right? So this is all about the tensors, right? And this is the prediction. Now tensors, the use of tensor is a different task, right? So in our next session or next to next session, we will see how to capture the image, how to convert that image into tensor, and then how it should be matched. It will be matched with the database image. That is a very interesting topic. So that is why I suggest you to subscribe my channel. You will get the notification of upcoming bootcamp videos, right? Bootcamp sessions, right? So today we have seen this, and in our next session we will see something new topic, get the notification of that. And if you are new to this channel, please subscribe my channel. Okay, thank you guys, thanks for attending.